All right, so today we're talking about fraction basics. So it's really important that even though we learned about fractions a long time ago, that we are reviewing those basic things, okay? So when you first started learning about fractions, you probably visualized them. For instance, we did something called modeling fractions. You heard that word before? Model fractions. We're not talking about like models in magazines or anything. Like if I said the fraction 1/4 and I wanted you to model it, would you have any idea what that was even asking you to do? What do you think? Oh, like a quarter, like from a dollar? Yeah, okay. What did you say? Draw a picture. So whenever it says to model something, they want you to draw a picture. You're right that a quarter is 1/4 of a dollar. All right. So, and that really, we could draw a picture of that. It'd be kind of hard, but. So, do you think there's probably a lot of ways that we could draw pictures of 1/4? All right. So we could. How many people thought of a circle? Some of you probably immediately thought of a circle, and then you'd have it into 4 parts, right? Because that's the denominator 4, and then 1. You shade in 1. Who thought of a rectangle or a square? Did anyone think of a rectangle or a square? All right, so again, we want 4 equal parts. We could do that in a lot of ways. I'm going to do it like that. We have 1/4. Now, those should all be equal, but, I'm not going to spend forever doing that. Is there any other way that you could think of besides rectangles and squares? What do you think? Okay, so she thought of 4 quarters, like 1, 2, 3, 4, and then she had one of them. She was, again, thinking about those quarters. That's good. Was that what you were thinking of over there? Oh, I think a rhombus is 4-sided, but they're really hard to draw correctly, right? Because what is a rhombus? What is the definition of a rhombus, besides it having 4 sides? All right, so it doesn't have right angles, but all the sides are equal in a rhombus. So some people call it a diamond or a kite, but it's really hard to draw correctly. So if you're drawing something to model, you want to do something that's as easy as possible, okay? So probably a rhombus, unless you're just an amazing artist, which I am not, then a rhombus might not be the best thing for us. Okay, so what is the purpose of simplifying fractions? Think about that for a second while you're writing. Simplify fractions. Basically, for notes, if I write it up here, then it's a good idea to write in your notes, okay? What would be the purpose of simplifying fractions? Yes, ma'am. Okay, so good. I'm glad you added that part on there. So getting it as small as you can get, but still having an equal amount to it, the same value. We don't want to change the value of it at all. So why do that? It'd be easier to do what? Okay, so it'd be easier for you to write down and finish the rest of the problem. The smaller the number, the easier it is to work with. So that would be the whole purpose of simplifying a fraction. So now let's review, how do you simplify? So let's do one of them that's pretty easy, 5/15. How would we go about simplifying this? What is your thought process? Don't just tell me the answer, your thought process. Five divided by 15. I'd want to do 5 divided by 15. Okay. And then what do I do up here? Okay, I stumped you. It's kind of when you're on the spot sometimes and it's like, whoop. All right, what do you think? All right, so divide them both by the greatest number they can both be divided by. That's called something. The greatest common factor, GCF. Remember learning about those? All right. So do you have to sorry, not multiply. No, no, no. Do you have to divide it by the greatest common factor? Always? No. Why is it helpful? Right. So if you don't use the greatest common factor, then you might have to simplify it multiple times. It's going to take longer, but it still works, right? So sometimes it's just easier to, if they're huge numbers, but they're both even, you can divide them by 2. So sometimes it's just easier. But this one, yes, 5 is what we definitely want to use. I don't think anyone would have come up with anything else, because the only other factor they have in common is 1, and is dividing by 1 going to help us? It's just going to be the same thing. All right, so 5 divided by 5 is, and 15 divided by 5. This is not work that I would expect you to ever have to show. Okay, so I don't need to see how you're simplifying it. Again, we are just reviewing the basics. Okay? So, does this work if your fraction is negative? Would you simplify the same way if your fraction is negative? So let's say we have a negative 5 over 15. So let's take a vote. If you think you would simplify this the same exact way, stand up. If you think you would do it something different, stay sitting in your seat. Oh, there's only 2 people that stood up. You simplify it the same way. You do it the same way. Okay. So good job for taking a risk by standing up. You were right. You trusted yourself. We're going to simplify this the same way. We're not going to worry about this negative sign at all. It does not affect anything, okay? When we simplify this, and we've already said that it's 1/3, we just take this negative sign, we don't want to forget about it, and we put it back out in front. That's it. Done. Now, something that I want to point out real quick, because people get confused about this. A negative fraction can be written kind of different ways. Most of the time, the negative sign is in front of the whole fraction, just like that. But you could write it just with the numerator, or you could write it just with the denominator, and it means the same thing. As long as there is only one negative sign, then it's a negative 1/3. Okay? Those all mean the same thing. So that's important to know. All right. Moving on. If we wanted to compare fractions, when I talk about comparing numbers, any kind of numbers, what do you use to compare? Ooh, I like that better. What do we compare in math? What symbols do we use? Good thought. Good thought. It is a symbol. That's it. So you did say equal. So remember when you were taught this, were you taught about alligators or Pac-Man? I still remember when I was in 3rd grade, it was a long time ago, and my teacher telling me about the alligator. What do you know about that symbol? If we're talking about the alligator, it likes to eat the bigger number. So if we add on teeth, I really like getting into it. So it likes to eat the bigger thing. So same thing always, all right? Greater than, less than, equal to. Oops, I erased that part. There we go. All right, so when we're comparing fractions, it gets a little bit more complicated. Now, when we have the same denominator, it's not that bad, okay? So same denominator. What operations, besides comparing and stuff, what operations, add, subtract, multiply, divide, is it important to have the same denominator? Okay, I'll ask it again. What operations, adding, subtracting, multiplying, or dividing, would it be important for us to have the same denominators? Addition and subtraction. So if we're adding and subtracting, we have to get those same denominators. We'll get into reviewing how to do that a different day, okay? But when we're comparing, it's very helpful for us to have the same denominators. Because since they have the same denominators, what do we need to compare then? You're really only comparing the numerators. So if the denominators are the same, you're going to compare the numerators. time did we get out of here? Someone's here. 11. Okay. So I'm comparing a 3 to a 1, and we all know that 3 is greater than, less than, greater than. We could also model. I don't think really anyone wants to have to draw pictures, right? But we could. We could draw a picture of 3/5. We could draw a picture of 1/5 and prove it that way. So if someone ever said, prove your answer, you could always prove it by modeling. But what are we going to do? This will be our last part. What are we going to do when we have different denominators? And we are not allowed to use calculators, remember? So we had a problem like 6 over 13 compared to 5 over 11. Ooh, what are we going to do for that? All right, tell me. So if we cross multiply, what is that going to do for us? So that'd be 66. That would be 65. And what? All right, so I don't think that cross multiplying is going to help us on this one. So you're saying that we could find the common denominator? All right, so that isn't a strategy. We could find the common denominator of 13 and 11, and then fix our numerators, and then compare our numerators. That's a possibility. Yes. We could turn them into decimals. So if we had a calculator, this would take us 2 seconds. Top divided by bottom, turn it into a decimal. Top divided by bottom, turn it into a decimal, and then compare our decimals. But we don't have calculators. So even though we don't have calculators, is it still possible for us to do? Yes. It's not fun, right? But we can do long division. Yay. All right, so let's practice that long division. You remember doing these? So way back when you were first taught how to divide, your teacher probably told you never put the smaller number inside, right? And here we are doing it. What do we need to do in order to make this work? Put a decimal. Great. You guys are really good at remembering what you're supposed to do. So don't forget to bring that decimal up into where your answer is going to go. So now we're going to pretend this is a 60. How many times does 13 go into 60? 4 times. So you may even have to kind of do math out to the side. That's okay. So see, that's 1252. Is that right? Now what? Remainder 8. That might not be enough for us. We probably need to keep going. So how do I keep going? Add a 0. So I can add as many zeros as I need to, correct? And I'm not saying that you need to go on forever, because you don't, okay? So 13 goes into 80 how many times? 6. It's kind of nice when we're all working together on this, right? So let's see, that'd be 1878. Gives me a 2. So I could keep going, right? Now, I'm going to maybe see if I can stop. I can always go back to it. But I'm going to go ahead and go over to my 5 divided by 11, and I'm going to work on that one. And if my first 2 digits are different than 4 and 6, then I'm good. I don't need to do anymore. So again, set it up the same way. I put that decimal after my 5 up into my answer. This one should be a little bit easier for us to do. 11 goes into 50 4 times. Oh, that's the same so far. I need to make sure I bring down another 0. 11 goes into 60. Oh, good. We have something different. All right. So none of the rest of this matters. And we do... Oh, that's a 5. Sorry. We do not need to keep on going, okay, because they're different. So think about money. 46 cents compared to 45 cents. Which one's greater? 46 cents. So that means that 6 over 13 is greater than 5 over 11. Okay? Let's make sure I am finished with all of my stuff, and I believe I am. So, I'm going to stop our notes.